So we focused on surface area, and now we're going to talk about volume of prisms and cylinders. The volume is the space a figure occupies. So like if we filled something up with water, that would be the volume. The cross section is a 2D shape formed when cutting straight through a 3D figure. So you can see below there are two examples of cross sections. When you cut through a cylinder, a cross section is a circle. And when I cut through a rectangular prism, my cross section is a square or rectangle. The other thing we need to be familiar with is Cavalier's principle, which says if two space figures have the same cross-sectional area at every level, then they have the same volume. And that's a really wordy, but basically what it's saying is if I have a prism and I have the same prism, but now I make it an oblique prism, they're still going to have the same volume. So I can figure out the volume of a prism the same way I could figure out an oblique prism or oblique figure of any sort. So the volume of a prism is base times height. Now base is again area of the base. So if we look at our figure, the volume here, to find the area of the base, it's a triangle. So it's half the height and the base, which is half of 3 times 4, which is 6. The height of my prism is 11. So my volume is going to be 6 times 11, or 66 centimeters cubed. Remember, we measure volume in cubic meters, or cubic centimeters. Cylinders have the same formula, area of the base times height. But remember, a circle is the base of a cylinder. So we can also look at the formula as pi r squared h, because pi r squared is the area of the base. R again is radius and h is height. So our volume is pi r squared h. Now our radius is 2 and our height is 4. So our volume is pi times 2 squared times 4, or 16 pi centimeters cubed. Let's look at two more examples. Find the volume of the figure. Well, the volume is base times height. The area of our base is 20 times 9, or 180, and our height is 8. So our volume is 180 times 8, or 1,440 cubic centimeters. Our cylinder is an oblique one, but we know from the Cavalier's principle that we find the volume the exact same way. Pi r squared h. The radius is 5 and our height is 15. So pi times 5 squared times 15, or 375 square units. Are there any questions, or if you have questions on these, please bring them to class. Find the volume of each figure. The first one, the volume, well, our bases are triangles. Again, we have right triangles, which makes it easy. Half of 16 times 12, which is 96. And our height is 10, the distance between the bases. So our volume is 960 cubic centimeters. The volume of our prism is base times height. Our base is 6 times 3, or 18. Our height is 4. So 18 times 4, or 72 cubic centimeters. And last but not least, the volume of our cylinder is pi r squared h. So our radius is 4, our height is 10. So pi times 4 squared times 10, which is 160 pi inches cubed. Hopefully your answers match. And again, pause the video, check your work, and then bring questions to class. And that's it for volume. Nice and simple, and we'll talk about volumes of other shapes at a later date.